Hello, my name is Brent, and today I would like to lecture about integer exponents. This presentation will be referencing Paul's online notes, which is a website you can find online for more practice with algebra and calculus. Topics of this lecture will be the definition of an exponent, many essential properties of the exponent, and we'll do multiple practice problems too. So let's get started. Let's start with the definition of an exponent. Given a positive integer a raised to a positive integer n, we define that a to the power of n is equal to a times a times a n times. We will multiply a n times by itself. So for example, 4 to the power of 3 is 4 multiplied by itself 3 times to get 64. Now, you may not be familiar with this dot symbol. This is for multiplication, but why are we using this instead of the usual times symbol, x? Well, it's because in algebra, we really want to reserve x as a variable and not an order of operation. So x is going to be a variable, and to avoid confusion, I'm going to use a dot to do the order of operation for multiplication. All right, let's continue. Now I immediately want to address an important concept, which is dealing with negative signs. So how does -2 in parentheses raised to the power of 4 differ from -2 to the power of 4 without parentheses? It comes to PEMDAS. So we want to evaluate parentheses first, then we want to evaluate exponents. So parentheses first, exponents second. So when we have -2 in parentheses raised to the power of 4, it's like multiplying -2 by itself multiple times to get a positive 16, because these two negatives cancel out, these two negatives cancel out to become positive. But when we have -2 to the power of 4 without parentheses, well, this negative sign would correspond to subtraction. So negatives would be evaluated after evaluate exponents. So we're going to evaluate 2 to the power of 4 first, and then apply this negative sign. So you can see we get two very different answers. So you want to keep this in mind whenever you're solving problems with negative signs and exponents. Let's talk about some more common exponential functions you'll encounter. Let's talk about the zero exponent first. So given a non-zero number, a, then a to the power of 0 equals 1. Note that this applies for negative numbers. So a negative 123 raised to the power of 0 is also 1. And this also doesn't have to be just integers. It can be fractions and rational numbers. So 1/2 to the power of 0 also equals 1. The only number that's not valid is 0 to the power of 0. This is not equal 1 because this 0 to the power of 0 is not a rational expression. Now we have negative exponents. So if you have a non-zero number a and a positive integer n, and you have a to the power of negative n, a quick trick to simplify this negative sign is to put a in the denominator, and then you can make n positive. So for example, 6 to the power of -2 is equal to 1 divided by 6 to the power of 2. So we put 6 in the denominator, and we make -2 a positive 2. Now one thing I want you to keep in mind of is what about 6 times x to the power of -2? This does not equal 1 divided by 6x squared. Why is that? It's because this -2 is only being applied to this x variable, meaning 6 needs to stay inside the numerator. So this would actually be equal to 6 divided by x squared. Now if this was 6 to the power of negative 2 times x to the power of negative 2, then we could write 1 divided by 6 squared x squared. So just keep in mind that. We'll go over many properties soon in the next slide. The following 2 slides highlight many important exponent properties that you'll encounter a lot. So I have the name of the property, its definition, and an example. So let's go through these one by one. So first we have the multiplication property. Again, given an integer a, and you raise it to one number n and another number m, multiplying these together returns the same base a. This time you add the exponents together. So for example, 2 to the power of negative 2 multiplied by 2 to the power of 5 is equal to 2 to the power of negative 2 plus 5, which becomes 2 to the power of 3, which equals 8. So when you multiply two numbers with exponents, you add the exponents together. Now let's discuss the exponential property. So if I have a to the power of n, and I raise that by another exponent m, now I multiply the exponents together. So 3 to the power of 2 raised to the power of 4 is equal to 3 raised to the power of 2 multiplied by 4. So we get 3 to the power of 8. Now let's do division. A to the power of n divided by a to the power of m is equal to a to the power of n minus m. So we subtract the exponents. So 4 to the power of 7 divided by 4 to the power of 5 is equal to 4 to the power of 7 minus 5, which is equal to 4 to the power of 2, or 16. So notice that for multiplication, we add the exponents. For division, we subtract the exponents. Now exponential functions are also distributive. So if I have this a multiplied by another integer b in parentheses, and I raise it to the power of n, that n will distribute to each base. So we get a to the power of n times b to the power of n. So for example, if I have 3 times x in parentheses raised to the power of 3, both the 3 and the x get raised to the power of 3. So we get 27 times x to the power of 3. And this also applies for fractions. So if I have a fraction a divided by b raised to the power of n, then both the numerator and the denominator will be raised to the power of n. So if I have 3 divided by 2 raised to the power of 2, the numerator 3 gets raised to the power of 2, and the denominator 2 also gets raised to the power of 2, and we get 9 divided by 4. Now this last property, distributive property 3, kind of goes off of the second one, distributive property 2. It's just another quick trick to resolve a negative exponent. If I have a divided by b to the power of negative n, I can flip a and b, I can reciprocate it, get b divided by a to the power of n, and then just like the last one, this n will distribute to the numerator and denominator. So if I have 3 divided by 2 to the power of negative 2, that's equal to 2 divided by 3 raised to the power of 2, right? I negate 2 and I flip my fraction, reciprocate it. So we get 2 squared divided by 3 squared to get 4 divided by 9. So notice this is the exact opposite of the last example, thanks to that negative sign, 2. All right, let's go through some more properties. All right, let's discuss some more properties. We have one more distributive property. And again, it's another trick to resolve a negative exponent. So if I have a times b in parentheses raised to the power of negative n, I can negate that n and place a times b in the denominator of a fraction. So if I have 2 times x in parentheses raised to the power of negative 3, I get 1 divided by 2 times x to the power of 3. So again, I flip it, reciprocate my fraction, so I put 2x in the denominator, and I negate this 3. And then this 3 will distribute to the 2 and the x. So I get 1 divided by 8x cubed. Now, this kind of goes off the last two properties, but again, if I have 1 divided by a to the power of negative n, I can just negate the n, and place the a in the numerator of my fraction. So we just get a to the power of n. So 1 divided by 4 to the power of negative 2 is just equal to 4 to the power of 2. I negate the 2, and I put 4 in the numerator, so we get 16. Now what about dividing negative exponents? Well, pretty simple trick again. You could subtract and get negative n minus a negative m, or to make it easier on yourself, you can flip a and b, take the reciprocal of the fraction, and then negate your exponents. So 2 to the power of negative 6 divided by 5 to the power of negative 2, you can negate the exponents and just flip the numerator with the denominator, reciprocate it. So you get 5 squared divided by 2 to the power of 6, which becomes 25 divided by 64. Now again, this exponential property, this k exponential will distribute with a and b. So this function becomes a to the power of n times k times b to the power of m times k. So if I have 3 to the power of 3 times x to the power of 4 in parentheses, raised to the power of 2, this 2 will distribute to 3 to the power of 3 to get 3 times 2 in the exponent. So we get 3 to the power of 6. This 2 will also distribute to the 4 to get x to the power of 4 times 2 to get x to the power of 8. And this is a very similar idea to the last property. You have the division of a to the power of n divided by b to the power of m raised to the power of k. This k will distribute to the numerator and the denominator, and those exponents will multiply once again. So we have 3 to the power of 3 divided by x to the power of 4 raised to the power of 2. This 2 will distribute with the 3. So we get 3 times 2 to get 3 to the power of 6. And this 2 will also distribute to the 4 to get x to the power of 4 times 2 to get x to the power of 8. So that is an exhaustive list of all of the exponent properties. I would take note of all of them because you will use them often when solving exponential functions. For the rest of the video, we will solve many examples to get familiar with these properties. Let's solve example 1. We want to simplify this expression as much as possible. So we have 2 to the power of negative 1 plus 4 to the power of negative 1. Well, I know with negative numbers in my exponent, I can negate the exponent and place my base in the denominator of a fraction. So 2 to the power of negative 1 becomes 1 divided by 2 to the power of positive 1 plus 1 divided by 4 to the power of positive 1. Now for any integer a, if you raise it to the power of 1, that's just saying a again. So this will just be equal to 1 divided by 2 plus 1 divided by 4. I have a least common multiple, 4, in the denominator. So I can multiply this 1/2 by 2 divided by 2. So I get 2 divided by 4 plus 1 divided by 4. Now we're just adding fraction. This is 3 divided by 4. So that was the answer to the first question. Let's solve example 2. I encourage you to pause the video if you feel confident in solving the problem on your own, then return here when you're ready for the solution. So this problem is going to rely on our knowledge of PEMDAS. We have parentheses, exponents, multiplication, division, addition, and subtraction. This is the order of operations that we will rely on. So first off, are there any parentheses in this expression? And the answer is no. Okay. Are there any exponents? Yes. We have negative 6 to the power of 2. This negative sign applies with subtraction, so we're not going to apply it. So we're going to evaluate 6 squared to get negative 6 times 6, which becomes negative 36, plus 4 times this 3 squared, we're going to evaluate to get 3 times 3 equals 9. We have no exponents left. Is there any multiplication that needs to be done? Yes. We need to multiply 4 times 9. So we'll have negative 36 plus 4 times 9. That is positive 36. There's no division to do. There is an addition to do. We have negative 36 plus 36. That equals 0. And that is the answer to this problem. Let's continue. All right, let's do example 3. Again, pause the video if you feel comfortable and try to solve it on your own, and return when you're ready for the solution. So again, I'm going to write down my PEMDAS. This is very important for these problems. Add and subtract. Okay, so do I have any parentheses in this expression? The answer is no. Okay, do I have any exponents that I can evaluate? And the answer is yes. So we know when we have negative exponents, a to the power of negative n is equal to 1 divided by a to the power of n. So to make this problem easier, we can take all of the numbers with negative exponents, flip them in the fraction, and then negate the number on the exponent. So we're not going to mess with 4 to the power of 0 because that's not negative. But this 2 to the power of negative 2 can go to the denominator, and we're going to make negative 2 a positive 2. We can do the same thing for this 3 to the power of negative 1. We can bring it to the numerator. It's still getting multiplied, but now it's a positive 1. Same thing with this 4 to the power of negative 2. We can move it to the numerator, and we're still just multiplying it. So now I can actually evaluate these exponents. So we remember, any non-zero number raised to the power of 0 is just equal to 1, multiplied by 3 to the power of 1. Any number raised to the power of 1 is just the same number. And then 4 to the power of 2 is 4 times 4, which is 16. And in the denominator, we have 2. So 2 to the power of 2 is just 2 multiplied by 2, which is 4. Now I'm going to get rid of this 4. 16 divided by 4 is equal to 4. So I can make this 16 a 4, and this 4 a 1. So we give 1 times 3 times 4. That is equal to 3 times 4, which is equal to 12. Let's move on to the next example. All right, let's solve example 4. Pause the video, try it out for yourself, then return for the solution. So I have this 3 that I can distribute to all of my base functions. So this will become 4 to the power of 3 times x to the power of negative 4 times 3. I have to multiply my exponents. Then y to the power of 5 times 3. So 4 to the power of 3 is 4 times 4 times 4. That is 64. X to the power of a negative 4 times 3 is x to the power of a negative 12. And y to the power of 5 times 3 is y to the power of 15. Now to make this even more simplified, I can take my x to the power of negative 12, negate the 12, and bring my x to the denominator. Again, it's only the x because x is the only term being raised to this negative exponent. So this will get us 64 times y to the power of 15 divided by x to the power of positive 12. Let's continue. Okay, let's try example 5. Again, I encourage you to try the problem by yourself before you watch me solve it. So I have these two parentheses values raised to different exponential functions. So I'm going to call this parenthesis 1 and this parenthesis 2. I'm going to try to simplify each of them individually, and then at that point, I'm just multiplying them. So let's simplify parenthesis 1. We have negative 8 times z to the power of negative 3 times y to the power of 2, all raised to the power of 2. So I can distribute this 2 to each value, so this becomes negative 8 to the power of 2. Notice that we have parentheses around the negative 8. We were going to keep that here. Then we have z to the power of negative 3 multiplied by 2. Then y to the power of 2 multiplied by 2. So negative 8 in parentheses to the power of 2 is equal to negative 8 times negative 8, which becomes positive 64. Then we have z to the power of negative 3 times 2, which is negative 6. Then we have y to the power of 2 times 2, which is positive 4. I can negate the negative 6 and move my z to the denominator to get 64 times y to the power of 4 divided by z to the power of 6. Okay, let's work on parenthesis 2. So we have z squared times y raised to the power of negative 4. Once again, I can distribute this negative 4. So we get z to the power of 2 times negative 4. And y will just be y to the power of negative 4. So this becomes z to the power of 2 times negative 4 is negative 8. Y to the power of negative 4 is just going to stay. And I can move both of these to the denominator of a fraction and negate the exponent. So we get z to the power of 8 and y to the power of 4 in the denominator. Now I can multiply these two fractions with each other to get my final result. We have 64 times y to the power of 4 divided by z to the power of 6 multiplied by 1 divided by z to the power of 8 times y to the power of 4. So I have nothing to multiply in the numerator. In the denominator, we're going to get z to the power of 6 plus 8, in parentheses, multiplied by y to the power of 4. That's going to be equal to 64 times y to the power of 4 divided by z to the power of 6 plus 8 is 14 times y to the power of 4. Now we can subtract our same bases and their exponents. So we're going to get 64 times y. Now we're going to subtract 4 minus 4. So y to the power of 4 minus 4 divided by z to the power of 14. So y to the power of 4 minus 4 would be equal to y to the power of 0, which is equal to 1. So remember the final answer up here. We're going to get 64 times 1, so just 64 divided by z to the power of 14. That is our final answer. Let's continue with the next example. Let's try example 6. Pause the video, try it yourself, and then continue. So immediately I can take out this c to the power of 0, right? That's just equal to 1. So this will just be equal to a to the power of negative 3 times b to the power of 2 divided by 6 times b to the power of negative 3 times a to the power of negative 4. Now I can subtract my likewise exponents, or I think it would be easier if we negate all of our negative exponents and flip to the other side of the fraction. So I can move this a to the power of negative 3 to the denominator. Now I'm not going to do anything with my b squared, right? So I can keep that up here. And we'll have a to the power of positive 3 now. Okay, that was good. This was good. My 6 is going to stay down here in the denominator. It's not raised to any negative exponent. Okay. I can move this b to the power of negative 3 to the numerator. So we get b to the power of positive 3. Okay, that one's good. Then I have this a to the power of negative 4 that I can also move to the numerator, get a to the power of positive 4. So this b squared times b cubed can become b to the power of 2 plus 3. And then this a to the power of 4 divided by a to the power of 3 can become a to the power of 4 minus 3. All of this is still being divided by 6. So this is equal to b to the power of 5 times a to the power of 1 divided by 6. We know that any non-zero integer raised to the power of 1 is just equal to the same integer. So this is going to just be equal to a times b to the power of 5 divided by 6. The order of variables doesn't matter. I'm just putting a first because it becomes first alphabetically. Let's continue. All right, let's try this problem. There's actually a couple of different ways you can solve it. You can distribute the 5 first, but what I'm going to do is get rid of these negative exponents first. So this x to the power of negative 3 can move to the denominator as long as I negate the negative 3. So that'll be x to the power of positive 3. Okay, that one's good. This x to the power of negative 2 can go to the numerator. So we get x to the power of positive 2. And this y to the power of negative 1 can also go to the numerator. So we get y to the power of positive 1. And then we still have this to the power, this 5 outside of the parentheses. Now again, I could go ahead and distribute this 5, but I see I have two like terms in the numerator and denominator that I can simplify even further. So this will become x to the power of 2 minus 3. And there's actually no denominator anymore, right? Because I just eliminated it. So let's clean this up a little. We just get x to the power of 2 minus 3 times y to the power of 1 to the power of 5, which is equal to x to the power of negative 1 times y to the power of 1 raised to the power of 5. Now I can actually make this a fraction again by moving my negative 1 exponent to the denominator and negating it. So this will be y to the power of 1 divided by x to the power of positive 1 to the power of 5. And now I have nothing else to simplify, so I'm going to distribute that 5 to the numerator and denominator. So this becomes y to the power of 5 divided by x to the power of 5. So you have some freedom as far as the order of operations that you want to do, as long as you're following PEMDAS. Let's solve example 8. First, I want to address this negative 2. How can I change this negative 2 to a positive 2? It turns out that I can move everything in the numerator to the denominator and everything from the denominator to the numerator if I just negate this negative 2. So this expression can become 6 times y to the power of negative 5 times z divided by 24 times y to the power of 3 times z to the power of negative 8, all raised to the power of positive 2. Now I can start simplifying these like terms. So first off, let's look at the integers. 6 divided by 24 is just 1/4. So I'll have 1 divided by 4. Okay, that takes care of this. Now I have y to the power of -5 divided by y to the power of 3. So this is y to the power of -5 minus 3. And we have z to the power of 1 divided by z to the power of -8. So this becomes z to the power of 1 minus a -8, which is the same as adding 8, also raised to the power of 2. So this becomes y to the power of -5 minus 3. That would be y to the power of -8 times z to the power of 9 divided by 4. All raised to the power of 2 still. And I can move this y to the power of -8 to the denominator by negating my exponent. So this will become z to the power of 9 divided by 4 times y to the power of +8 raised to the power of 2. Okay, I have no more simplification to do inside the parentheses, so let's go ahead and distribute this too. So this becomes z to the power of 9 times 2 divided by 4 to the power of 2 times y to the power of 8 times 2. And this becomes z to the power of 9 times 2 is 18. 4 to the power of 2 is 4 times 4, or 16. And y to the power of 8 times 2 is y to the power of 16, because 8 times 2 is 16. And that's our final answer. Let's do one more example. Let's solve final example 9. This time I have some parentheses within my fraction raised to different exponents. So I'm going to simplify the parentheses first by distributing this -3 to my parenthesis in the numerator, and this -1 to my parenthesis in the denominator. So my parenthesis numerator will be 2 to the power of -3 multiplied by p to the power of 2 times -3. And then we're multiplying q to the power of 4. In the denominator, we're getting 6 to the power of -1 times q to the power of -1 times p to the power of -7. Okay, let's simplify those exponents a little more. So we get 2 to the power of -3 times p to the power of 2 times -3, which is -6, times q to the power of 4, divided by 6 to the power of -1 times q to the power of -1 times p to the power of -7. Let's get rid of all of these negative exponents. So this 2 to the power of -3 can drop to the denominator and become 2 to the power of +3. This p to the power of -6 can also drop to the denominator and become p to the power of +6. Q to the power of 4 is positive, so it will stay up here. This 6 to the power of -1 can move to the numerator and become 6 to the power of +1. Same thing with this q. You can move it up here. And this p to the power of -7 can move up here as well, become p to the power of +7. Okay, let's simplify a little more. So we have q times q to the power of 4 and q to the power of 1. So this will be q to the power of 4 plus 1. 6 to the power of 1 is just 6. We have p to the power of 7. 2 to the power of 3 is 2 times 2 times 2, which is equal to 8. So we get 8 times p to the power of 6. We can add these q exponents. So we get q to the power of 5. 6 divided by 8 can be simplified to 3/4. So we get 3 divided by 4. And this p to to the power of 7 divided by p to the power of 6 can become p to the power of 7 minus 6 in the numerator. So we end up with 3 times q to the power of 5 times p to the power of 1 divided by 4. That's our final answer. Alright, thank you for watching my lecture. I hope you enjoyed it. Again, my name is Brent, and for any questions, comments, or video suggestions, feel free to contact me at my email. Thank you, and have a nice day.